Welcome students. Today's lecture will be on Cartesian product. Before we start the Cartesian product, let us try to do some examples and try to understand the importance of the notion of ordered pairs. Before we proceed, let us do some examples. Now, we have a set A consisting of 3 bags. Let us name it as x, y and z. So, which means that x is a bag, y is a bag and z is a bag. Of course, each bag can contain as many balls, but let us restrict that a bag can at most contain only one ball and you can put only one ball in it. So, let B denote set of all balls with colors either blue or red. So, the first set contains exactly 3 bags. We have named it as x, y and z. We have another set consisting of balls, but our interest lies only on the colors of the ball. The colors of the ball are exactly blue and red. Now, what are the various possibilities through which you can fill those bags? You can fill the bag x with a blue color ball, or you can fill the bag x with a red color ball, because we know that each bag can contain only one ball. The second one, similarly, y, the bag y, you can fill it with a blue color ball or y with a red color ball, right. Again, you have the z color bag, z named bag, z bag, wherein you can put the blue ball or z with a red ball. What is that we have? Now, that what is that we have here is that to each color we have associated a bag, and to each bag we have associated a color of the ball. So, let us write all those things as pairs. First one says you have chosen the bag x and you are trying to put the blue ball inside it. The second one says you have the bag x and the red ball is there. Third one, the bag y with the blue colored ball. Fourth one, bag y with a red colored ball. Fifth one, the bag z with a blue colored ball, and finally bag z with a red colored ball. Totally we have 6 possibilities. Right. So, given any, let us write it formally as given any A in A and B in B, we obtained a pair. So, we obtained a pair A comma B. Well, let us go to the second example, which I will call it as vehicles and their name plates. Let A denote the set of some of the states, let me call it as Delhi, Madhya Pradesh, Uttar Pradesh, Andhra Pradesh, Tamil Nadu. We have 5 states, and on the other hand let me have the set B as the numbers 0 1, 0 2 up to 0 9. What we have is we have 2 sets A and B. The first set A consisting of 4 5 states and the set B containing 9 numbers. Supposing that I wanted to form a name plate or a number plate for a vehicle. Suppose that the person is from Madhya Pradesh. What is that possibility? So, the possibility of a person, well not a person, of a name plate, the possibility of a name plate for a person coming from say MP is, well let us have it as MP 03. This is one of the possibilities. Well, this is not the usual one that we see in day to day life, but this is one of the possibilities that we have. In fact, what is that is happening? Given A in A and small b in capital B, the pair A comma B, right. The pair A comma B tells you, the first A tells you the state in which the vehicle belongs to, right. Pair A comma B says the following. A denotes the state, B denotes the number of the vehicle. So, in the last 2 examples, we saw that there are situations which gives rise to pairs A comma B. So, let us make it formally and define things like given sets A and B and elements A comma B with A in A and B in B, the pair A comma B is called an ordered pair. Right. The pair A comma B, this pair I will call it as an ordered pair. Well, let us look at one more example. Let us look at all those elements x comma y in all those x comma y such that x and y or x comma y are real numbers and x squared plus y squared equal to 1. By now, it is clear that this set represents a circle, right. We are only trying to write a circle as a in the form of a set. So, elements of this set are elements belonging to a circle or those points lying on the circle are examples for ordered pairs. Right. Now, having said this ordered pairs, let us go ahead and then define the notion of what is known as the Cartesian product of two sets. So, let me just write down definition. Let us begin with the definition. Let A and B be any two sets. The Cartesian product of A and B denoted A cross B is defined as so this is again a set A cross B equal to set of all ordered pairs A comma B with A in A and B in capital B. So, this Cartesian product consists of all ordered pairs with the first element coming from the set A and the second element coming from the set B. So, the examples that we had initially, so the examples that we had initially, the first example is an example for the Cartesian product In fact, we had our set A as three bags named x, y and z, the set B as blue and red. So, A cross B, this consists of all possibilities that means what is that which ball, which colored ball are we going to put inside the bag x or y or z, that is what it says. Now, let us look at the second example. It says about what is known as the name plates of a vehicle. So, again this is an example, the second example is also an example for the Cartesian product. Now, let us look at the third example, that is the set circle sets a set well, let us write it as this way, the ordered pairs x comma y such that x and y are real numbers and x squared plus y squared equal to 1. First thing that we will have to see is that this set, well, we know that this is a circle, this is what we observed in the last prime. This set is not a Cartesian product of two sets. This set is not a Cartesian product of two sets. That is one of the observations. So, why is it this set is not a Cartesian product of two sets? Let us look at something. So, for example, 0 comma 1, this belongs to, this is on the circle, similarly 1 comma 0 is also on the circle, we have 0 comma 1 on the circle and 1 comma 0 on the circle, which means what does this tell us? So, suppose I write the set, let me call the set as A, let me call it as some S. Suppose S is of the form A cross B. Now, since 0 comma 1 belongs to A cross B, that implies that 1 belongs to B. Similarly, the pair 1 comma 0 belongs to A cross B, that implies that 1 belongs to A, whereas the pair 1 comma 1 does not belong to S, because why is it so? 1 square plus 1 square, which is in fact 2, is not equal to 1. Therefore, 1 comma 1 does not belong to S. Therefore, S, that is the set of all pairs which lie on the circle, is not a Cartesian product of two sets. Not all sets, this example gives us the fact that not all sets can be written as a Cartesian product, although a set can have ordered pairs, that does not mean that it is a Cartesian product of two sets. Fine. Let us look at some of, so let us, before we go to the next example, let us make some remarks. The first one, suppose that you have two sets, let us look at A cross B, consider A cross B and B cross E. Are these two sets one and the same? On what basis and how? So, A cross B consists of elements of the form A comma B. This is A cross B with A in A and B in B. This is A cross B. while the other one B cross A consists of all opposite pairs B comma A, such that B in B and A in A. The question is, can't we not write it as A in A and B in B? Yes, there is no difference between writing it as A in A and B in B, but it is only this order that makes sense. It is because of this order, right, these two sets are totally different. The pair, so A comma B is not equal to B comma A, which means A cross B and B cross A are totally different sets. Now, one more thing, the second one, given two elements A comma B and C comma D from A cross B, we say that A comma B is equal to C comma D if A equal to C and B equal to D. So, what it says is that pair or at every position the element should match. In the first position, on the left we have A and on the right the first element is C in the first position. Similarly, for the second positions we have B and here we have D, these two should match. If these two matches at every position, then we say that these ordered pairs, they are equal. So, let us look at an example or a problem. Suppose x minus half plus y comma x plus half plus y x, this is equal to 2 comma 3, right. What we have is x minus half plus y and the ordered pair x minus half plus y and x plus half minus y, this is same as 2 comma 3. Find x and y. So, on the left we have an ordered pair and on the right we have an ordered pair, and what is given is that these two ordered pairs, they are equal. So, how to solve this? What is that is given to us is that the ordered pairs, well, let me write it as x plus y minus half and x minus y plus half is 2 comma 3. So, that implies that x plus y minus half is same as 2 is equal to 2 and x minus y plus half, this is equal to 3. So, let us solve this, let us add these two things. What it gives is that 2 x equal to 5, that implies x equal to 5 by 2. Now, let us write down the same set of equations, x plus y minus half equal to 2 and x minus y plus half equal to 3. Let us subtract the first one, let us subtract from the first the second. So, x, now that x gets cancelled and what we will have is 2 y minus 1 equal to minus 1. Sorry, minus 2 y minus 1 equal to minus 1, that shows that y is 0, right. So, x and y, so therefore, x equal to 5 by 2 and y equal to 0. Fine. Now, let us look at some more examples Some more examples. Suppose A is a set and we are given that 0 comma 1 minus 1 comma 0 is in A cross A. Find A. What is that we know is that the two pairs, ordered pairs 0 comma 1 and minus 1 comma 0 are in A cross A. How to find A? The first question that we would like to ask is how many elements are possible in A? Well, 0 comma 1 belongs to A cross A, that implies that 0 belongs to A and 1 belongs to A. Similarly, minus 1 comma 0, this belongs to A cross A, that implies minus 1 belongs to A and 0 belongs to A. Therefore, based on the information that is given to us, what we know is that minus 1, 0, 1, this set is exactly our A. So, A consists of 3 elements minus 1, 0 and 1. Therefore, A cross A is going to look like minus 1 minus 1, minus 1 0, minus 1 1, 0 minus 1, 0 0, 0 1, 1 minus 1, 1 0 and finally 1 1. How many elements does this A cross A contain? This A cross A contains exactly 9 elements. So, let us again write it as a remark that if A and B are any two sets with number of elements of A equal number of elements of A as P and with number of elements of B as Q, then the number of elements in A cross B is P Q. So, the total number of elements in A cross B is total number of elements of A times the total number of elements in B. Therefore, the total number of elements of A cross B is same as the total number of elements in A times the total number of elements in B. Fine. So, let us look at the last example. Let us look at the previous example once again. The set A, what we found is has got minus 1, 0 and 1. So, number of elements of A is 3, that implies that the number of elements of A cross A is going to be number of elements of A times number of elements of A, which is going to be 3 times 3, which is 9. But well, now let us look at, let us write down once again what this A cross A is: minus 1 minus 1, minus 1 0, minus 1 1, 0 minus 1, 0 0, 0 1, 1 minus 1, 1 0, and finally 1 1. Let us count the number of elements. So, you can notice that with each element we are pairing together with another 3 more elements, thus we have ended up with 9 elements. So, A cross A has got 9 elements. Now, let us do one more example. Let A be a set whose Cartesian product with itself, with itself, that is A cross A, has got 16 elements. So, we are given a set A such that when you take the Cartesian product of A with itself, then it is going to have 16 elements. This is the first clue that we are given. That means, A cross A has got 16 elements. That means, A is going to have 4 elements. It is going to have 4 elements, fine. Now, suppose that we know that 1 comma 2 and 3 comma 4 are in A cross A. Find A and A cross A. How to find A and A cross A? The first observation that we made here is that, so what is that is given? The number of elements of A cross A is 16. That implies, as we did in the previous remark, that number of elements of A is going to be 4. Now, the pair 1 comma 2, this is in A cross A, and so that implies 1 and 2 they both are in A. Similarly, 3 comma 4 they are in A cross A. That implies both 3 and 4 are in A. Therefore, the set A consists of 4 elements 1, 2, 3 and 4. Now, A cross A, it is going to have all 16 elements with orders, with pairs consisting of elements lying from 1 to 4. Well, this is going to be 1 comma 2, 1 comma 3, 1 comma 4, well 1 comma 1, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 4 comma 1, 4 comma 2, 4 comma 3 and finally 4 comma 4. So, these are the possible 16 elements, or in fact, the only possible 16 elements of A cross A. Let us do one more example from geometry, and let us try to do higher examples based on this. Most of us are aware of what is known as the R2, the two dimensional plane. What is this R2? R2, this consists of all ordered pairs x comma y with x and y as real numbers, where x and y are real numbers. You can notice that this is exactly equal to r cross r. So, this is an example for a Cartesian product. So, the usual two dimensional plane is exactly the Cartesian product of real numbers with itself. Let us also look at the same thing R 2 from a different point of view. Let us look at the diagram, following diagram. Supposing that I am here and I have a point. The only thing we are given the following information, one is r, which is exactly the distance from the origin to this point, right. This is my point P, I have a point P and I am given this distance r and the angle that it makes with the x axis. These are the two things that I am given, let me call it as theta. So, this R 2 I can write it as all those ordered pairs r comma theta with r positive, well r positive and 0 less than or equal to theta less than 180 degrees, or in fact not 180, it should be 360 degrees, right. You have this many things. In fact, so I should remove not just R 2, the way I have written it should be, I should remove this does not contain the origin 0 comma 0. So, in order that I include this 0 comma 0, I should have written it as r greater than or equal to 0 here. So, when the distance is, what we need is that the distance is bit positive, that is what we expect. But if you look at this one, this set is a Cartesian product of two sets. These are what are known as polar coordinates, which most of you must have seen in a course on geometry, right. What you have is the set of polar coordinates, but this set is almost like a Cartesian product, that is what we have, right. But anyhow, if I am going to include r greater than 0, I can write it, this is going to be a well, this looks like it is not a Cartesian product, sorry, looks like it is not a Cartesian product, but one can write this as a Cartesian product. How to write this? This set is exactly equal to all those r in R such that r greater than 0 cross all those theta such that 0 less than or equal to theta less than 360 degrees. This is an example for a Cartesian product. Fine. So, now having said all these things, let me make one more remark on the Cartesian product. If A and B or any two sets with at least one of them being infinite, then A cross B is also an infinite set. In the earlier case, both the sets are infinite and therefore, the Cartesian product is also infinite. So, let us do one simple example. What is that we have in one more example? Let us choose A as just small a, small b and small c, and capital B as 1, 2, 3 etcetera, etcetera. Now, A cross B, it is going to contain A comma 1, A comma 2 dot dot dot, B comma 1, B comma 2 dot dot dot, and C comma 1, C comma 2 dot dot dot. So, although A is finite, but since B is infinite, this says that A cross B is infinite. Now, let us do one more example. This is again a familiar example, a known one for all of us. The first, let us look at R 3, the 3 dimensional plane. This is the usual one that we look at, 3 dimensional plane. What is this 3 dimensional one? R 3. This, as we all know, consists of all x, y, z triples, such that x, y and z all 3 are real numbers. The question is this a Cartesian product of 2 sets? There are 2 ways of looking at this one. Let us try to identify this set as a Cartesian product of 2 sets first, and then let us see what is the other possibility. I can also write this as x comma within brackets y comma z, such that x, y and z all these are real numbers. Once I have this, I can write this as R cross R 2. The natural question is, why can't I separate x, y, z as x comma y comma z? Yes, why not this way, x comma y comma z as the first 2 entries and then separated by a comma for the third one. Why not this one? So, this is in fact this is right, and one can identify R 3 with R 2 cross R. So, what we have done is that the canonical, what we see in the nature, the 3 dimensional plane is written as the Cartesian product of 2 sets. A natural question that arises at this stage is that, is it possible to write this as R cross R cross R? Does it make sense? Yes, one can write R 3 as R cross R. Now, what is the meaning of this R cross R? So, let us go a step further and try to define the notion. So, let us begin with a definition. Let A 1, A 2 and A 3 be 3 sets. Then the Cartesian product of A 1, A 2 and A 3 denoted A1 cross A2 cross A3 is defined as A1 cross A2 cross A3 equal to all those triplets A1, A2, small a1, small a2, small a3 with given that A1 in capital A1, small a2 in capital A2 and small a3 in capital A3. In the first case what we had is ordered pairs or it is the 2 tuple. Now, we have a triplet or a 3 tuple with the first element coming from A1, second element coming from A2 and the third element coming from A3. So, now let us go back to our previous example of the R3, the 3 dimensional plane. So, R3, so this is exactly same as R cross R. So, this is an example for a Cartesian product with 3 sets, Cartesian product of 3 sets. Let us do one more problem at this stage. Supposing that we are given this one x plus y plus z comma x minus y minus z and x plus y minus z, this is equal to 1, 2, 3. Suppose this is what is given to us. Find x, y and z. You are given this. So, how to solve this problem? So, before I proceed with the solution to this problem, let us make one more remark which is exactly the same as what we remarked for the case of Cartesian product of 2 sets. If A1, A2, A3 or any 3 sets, if you have any 3 sets, then and if so, if you have any 3 sets and if the triplet A1, A2, A3 and also the triplet A1 dash, A2 dash, A3 dash, if you know that these 2 triplets belong to A1 cross A2 cross A3 and also that you know that the triplet A1, A2, A3 is equal to A1 dash, A2 dash, A3 dash. That implies that A1 equal to A1 dash, A2 equal to A2 dash and A3 equal to A3 dash, which means that at each position they should match, at the each coordinate should match at each position they should match. Only then you say that those triplets, 2 triplets are equal. If the each coordinate wise or each position wise, if the real numbers match, if the elements match, then you say that such 2 triplets are equal. Now, let us go to the solution for the problem. How to solve this problem? Based on what is given what is that we are given is that on the left we are given a triplet x plus y plus z, x minus y minus z, x plus y minus z equal to the triplet 1 2 3. Based on the above remark, it can be said that x plus y plus z equal to 1, x minus y minus z equal to 2 and x plus y minus z equal to 3. Let me call the number each equation 1, 2 and 3. Adding 1 and 2, we get 2 x equal to 3, that implies that x equal to 3 by 2. Now, adding one and 3, if I am going to add 1 and 3, what will I have? We get 2 x plus 2 y equal to 4, but what we know is that x is 3 by 2. So, let me just substitute x as 3 by 2. So, that implies that 2 into 3 by 2 plus 2 into y equal to 4, that implies 2 y equal to 4. So, 2 into 3 by 2 which is 3, 4 minus 3 which is 1, that implies y is 1 by 2 which is half. Now, finally, let us look at the first one, x plus y plus z equal to 1. This is what I have. Now, the value for x is 3 by 2 and the value for y is 1 by 2 plus z equal to 1. That implies 3 by 2 plus 1 by 2 which is 2 plus z is 1, that implies z equal to minus 1. Therefore, the values for x, y and z are 3 by 2, 1 by 2 and minus 1 respectively. So, in the next lecture we will do some more problems based on these and also we will do some more examples for Cartesian product and subsets of Cartesian product. Thank you all.